Folks, the USDA is right. I 100% agree with USDA about water bath canning low acid foods. There, I said it and I mean it. And anyone that disagrees with me, you're not just disagreeing with me, you're disagreeing with science. You see, according to the USDA, water bath canning low acid foods is safe. And before anybody comes at me, let me refer you to Guide 1, page 8 of the USDA's very own complete guide to home canning, the 2015 revision, which says, and I quote, "The time needed to safely process low acid foods in a boiling water bath canner ranges from 7 to 11 hours. The time needed to process acid foods in boiling water varies from 5 to 85 minutes. And just to be clear, it's not taken out of context. It is the paragraph that is in is about how resilient spores are and how much more efficient pressure canning is at destroying them, assuming the need to achieve that same 12 log reduction. So with that unpleasantness out of the way, we can dig into a few points that I think are interesting about this. The first and the most obvious is that the USDA really wants you to pressure can low acid foods. Second, the end goal of the USDA's guidelines is a home canning process that achieves the same 12 log spore reduction for home canned foods that the commercial canning industry is required to meet. Now, the way that that's accomplished and while broadly adhering to the same principles is obviously different due to the sophistication and just the sheer scale of the industrial canning process. Now, third, at least in my opinion, and I'm just a dude on the interwebs, the USDA's 12 log reduction is extreme overkill, particularly for home canners for a couple of reasons. One, and the most important, is that as home canners, we have complete control over the quality of our food. We're not using overripe, damaged, or grossly contaminated stuff. So there's no reason for us to assume the worst case scenario that the USDA uses when they inoculate with spores. Now, two, the math we're talking about a little bit later reflects some significant differences between very small numbers when we're talking about spore reductions. That brings us to another really important topic that doesn't get talked about enough, and that's hazard versus risk. A hazard is a potential source of harm, and a risk is a likelihood of that harm actually occurring. And then with risk, you can have perceived risk and real risk. You know, we perceive something to be risky, but is it really risky? How often does it occur? So, you know, in our case, the hazard is botulism, which is undeniably bad if you catch it. And even though the chances of dying from foodborne botulism today are very small, thanks to modern medicine, it's still a very serious illness. And I think we can all acknowledge that and agree on that that's the hazard that we're talking about here. So what is the risk? And I'm talking about real risk here, not just a perceived risk. So if you pressure can according to the USDA's published guidelines, the real risk of foodborne botulism is essentially zero. That 12 log reduction, even when starting with their worst case testing numbers, eliminates so many spores that there's really about a 1 in a trillion chance that a spore survived that process. Now, if you do a boiling water bath process with the same, and you start with the same worst case numbers, the results are much worse. In that case, you'd find a spore in about every 1,600 jars. And if you wanted to quantify that for us, that means we would have one jar contaminated with botulism every 2 years. But, and this is important, what happens if you do a boiling water bath assuming a normal botulism spore load from typical garden soil? Remember, we're talking about a normal level of 0.01 to 0.1 spores per gram of food grown in average garden soil. And this isn't even considering the effects that actually washing or cleaning the food would have prior to being processed. Now, using that number and under those circumstances, and assuming a 1 log reduction takes about 25 minutes, a 3-hour boiling water bath would result in an 8 log reduction in spores. But because we started with a much smaller number, that means there's only about a 1 in a 1.5 billion chance that a spore survived. Now that's less than a 1 in a trillion, so it's more risky, but it's a very, very, very small risk. So what do those numbers mean in context? Well, you have about a 1 in a trillion chance of being killed by a vending machine falling on you while you're winning the lottery. I mean, heck, you got better odds of winning the Powerball jackpot twice, by about 2.5 times, than you do of that happening. Likewise, the real world examples of a 1 in 1.5 billion chance of something bad occurring to you are equally absurd. So the real risks here for both of these scenarios is effectively zero. Now, that means it's safer than anything we encounter in our daily lives, provided everything goes right and we don't make any mistakes. Now, we of course know the risks aren't actually zero because a handful of people contract foodborne botulism every year, and though very few die thanks to modern medicine, people aren't perfect. There's going to be mistakes made, and that's why the USDA says that if you have any doubts about the food that you canned, bring it to a boil and boil it for 10 minutes after opening and before you consume it. At the end of the day, what this boils down to, folks, is your personal tolerance for risk. USDA guidelines and tested recipes are incredibly safe with a huge safety margin, and they're great for canners at all levels, and we still use them. I mean, that's the way we learned to can. But as we talked about above, and while only begrudgingly so, the USDA does acknowledge that water bath canning is a safe way to preserve low acid foods. They just don't want you to do that because it is not as safe, even though we're talking about really small risks. So it's gonna take more time. It's likely going to use more energy to water bath than pressure can, and the margins for error are going to be smaller, but mathematically at least the results are essentially zero remaining viable spores regardless of the method you choose. Again, it's your kitchen, your rules. Study up, do your own research. Do not trust a canning nerd on the internet. And in the words of the great meteorologist philosopher Ryan Hall, don't be scared, be prepared. Happy canning.